Welcome to Module 2, Lesson 22, Solving Equations Using Algebra. Lesson 23 will be the same, be talking about the same subject. And then, of course, following Lesson 23 will be the end of Module 2 assessment. Okay, so these are the last two lessons before that end of module assessment. Alrighty, well, here we go. This begins this way, a classwork explanation here. And it says here, I'm reading right up here from Classwork. In this lesson, you will transition from solving equations using tape diagrams, to solving equations algebraically by making zero. Making zero. Very interesting, huh? And this idea of making zero. We talked about that actually from in Lesson 21. And using additive inverse and making one by the multiplicative inverse. Okay? Justify your work by identifying which algebraic property you use for each step in solving the problems. Explain your work by writing out how you solve the equation step by step and relate each step to those used with a tape diagram. Okay. Again, I had said this before, but this whole program, it makes the assumption that we have all been using these processes since we were very young. Okay, and that will be the case for younger kids today, but for you guys, 7th graders, you haven't had so much experience with tape diagrams, but I think most of you have actually used them at my urging, so I do appreciate it, and it surely will help with this lesson. Okay. So even though most of us have just started using tape diagrams, you are about to transition away from them. And this idea of transition, those of you who may not know what that word means, but it means moving from one thing to another. Okay, so we're going to transition, move from these overtly diagrammatic tools to strictly to algebra, using algebra symbols and language per se. Okay, and the two things we're going to be doing is we're going to be using, as I said right here, the additive inverse. Okay, so additive inverse, and we've talked about this quite a bit, and I've been really impressed at how many of you know have really locked on to this one. So the additive inverse of 1, of course, is -1. All right. So, and these two, of course, add up to 0. Okay. So that's the idea of making 0, is adding any number or combining any number with its additive inverse. Okay. And that's kind of what we talked about again in Lesson 21. And now making 1 through multiplicative inverse. Again, we've done this before. If we were going to make 1 out of 5, okay, we would multiply it by its multiplicative inverse, okay, which is 1/5, all right, and so 5 over 5, and of course that equals 1, okay, so this is this idea of using the multiplicative inverse, and the inverse operation of multiplication, of course, is division, okay, and that's pretty much what we've done right here. Okay, dividing by 5 is the same as multiplying by its inverse, or its reciprocal, 1/5, because it's 5/5, gives us 1. Okay, let me get rid of all, let me do that, get back, okay, let me just wanted to get rid of all these here, they're all in our way. Okay, so let's go ahead and start this. And let's go ahead and read. I'm going to read this to you. You can read this along with me. Hopefully you do that all the time. Example 1 is Yoshiro's new puppy. Yoshiro has a new puppy. She decides to create an enclosure, okay, like a pen, an enclosure, for her puppy in her backyard. The enclosure is in the shape of a hexagon, six-sided polygon, with one pair of opposite sides running the same distance along the length of two parallel flower beds. So we have all kinds of language here, don't we? Okay, one pair of opposite sides running the same distance, okay, along the length of two parallel flower beds. Okay, so there are two boundaries at one end of the flower beds that are, so we've got two boundaries at one end of the flower beds that are 10 and 12 feet respectively. Okay, so we have some numbers here. We have 10 feet, we have 12 feet, we have this idea of parallel, we have opposite sides that are same distance, okay, and at the other end, the two boundaries are 15 and 20 feet. So here are some more numbers respectively. If the perimeter of the enclosure is 137 feet, what is the length of each side that runs along the flower bed? Now that is a lot to take in, okay? A lot to take in. So, thankfully, we have been given a good deal of room on this piece of paper to draw a picture, and that's what I would highly recommend. Okay. So, if you've noticed here, we're talking about a hexagon. So we have talking about a figure that has a shape that has 6 sides, and if you are counting here, you notice they have given us the length of 1, 2, 3, 4 of those sides. So 2 sides are our unknown. What is nice about those 2 sides, as you can see, they are right here, one pair of opposite sides running the same distance. They are the same length. Okay, so if I were to draw this, firstly I can just go ahead and draw my 2 parallel sides. Okay, there they are. All right, and this is all going to be very rough. Now these are unknown, and we could write them as X, but we haven't used N at all. I don't think at all this year. But N is also a very popular letter to use for an unknown. Okay, and let's go ahead and plug in these. So we had one end. They called it the boundaries. I'm not quite sure. This kind of would throw me actually, but they are 10 and 12 feet. This one looks more like 12. So let's say this is 12 feet. I'm going to use that symbol for feet. Always want to pay attention to units, okay? So 10 and 12 feet there, all right? And they said on the other side 15 and 20 feet. And okay. Let's just say this is 20 feet. This is 15. Again, this is not to scale, okay? And we've learned about scale, okay? But this is definitely not to scale here. It's just to help, us out. So these are the things we know, but these are the things too we don't know, okay? And we are going to solve for those. Oh, and we do know one more very important piece, is that the perimeter is 137 feet. And again, for those of you who might still be having difficulty with this idea of perimeter, of course, is the measure all the way around. Okay, so that's our perimeter. Okay, and we know that equals 137 feet. All right? Now, a very basic equation we could write to to model this or to put this model in as an equation form, we could say n plus n, because that's what perimeter is. It's all about excuse me, adding all the sides. So n plus 15 plus 20 plus 12 plus 10 equals, sorry, we're running out of room here, 137. Okay, so very simply, so what I've done here, firstly, I've drawn a figure here. I've drawn my diagram here. Okay, this idea, drawn that, kind of just to get a real picture of what we're talking about. Then I went ahead and made an equation here, because that's basically what we're doing. We know all of those, and we just don't know these two here. Okay, so that's our basic equation. Okay, so let's go ahead. Next thing I'd like to do is let's go ahead and draw a tape diagram to go along with this equation. So why don't you pause right now and go ahead and give that a whirl, and come on back, and I'll have one waiting for you. Okay, so here's what I have. I just went ahead and transferred my my equation back up top here. Okay, this is what I had on my other page. And then I went ahead and made my tape diagram. Now I have, of course, my tape diagram is going to have 1, 2, 3, 4, 5, 6 parts, because each one of those parts or sections of this diagram, tape diagram, represent the sides of the dog enclosure. Okay, the puppy yard. Okay, because it's a hexagon, so there are 6 sides. All right, so I've gone ahead and used my n for my 2 unknowns here. Okay, and then I've again plugged in. I know I have 137 is this entire tape diagram is going to equal that, but I also know that this right here, what I know already, I've added those up, and they equal 57 feet. Okay, so all I need to do then, and again with tape diagrams, so very clear, I take 137 and I subtract away the 57, and I'm left with 80. Okay, because I've taken this right here, 137, and subtracted away what I know, 57, and I get left with 80. Now this 80, I know, is going to be right here. Okay, that's 80. But what's really helpful in this case is that, and it won't always be the case, but I know that these two are equal. Okay, these are equal because they told me before they are the same size. So all I have to do then is divide by 2, and I know that each one of those is going to be 40 feet. Okay, so in the end, n equals 40. So I could go back to my original diagram here, and I could, right here, n equals 40. Wherever I have n, I have 40. And if I went ahead and added all those, I know that they will equal 137 feet. Okay, so now we're going to take this step and look at them side by side, or one over the other. Here is my tape diagram. I've just redrawn it just to actually take it apart a little bit more, because I'm going to use all of these numbers here to create an algebraic expression, okay, an algebraic equation. All right. So from this I can see, before I didn't have it written this way, but I do have 2 n's here, okay, 2 n's, and I have 57 that I know, and I know those 2 added are going to equal 137. So all I have to do then is write that first. So 2n plus 57 equals 137. Okay, so now I'm going to solve for n. Okay, so now we're going to practice right here. We're going to practice using our subtraction an addition, identity, equality, multiplication, multiplicative identity, additive inverse, all the rest that we've been talking about, okay? So the goal always, as we've talked about again and again, is to isolate the unknown, okay? So we're trying to isolate n on one side, and we usually like to have that unknown on the left if we can. It's always possible, but sometimes it's a little messier than other times, okay? But we're lucky right now we have our n on the left already. Now we not only want to isolate the n, but we want to turn it into one end. So we want to know in the end, we want an equation that looks like this: n equals something, okay? N equals something. So that's what we want on this left side, is just an n. Now the way to get there is we have to do a few things, okay? We have to manipulate that that expression right now, that 2n expression, all right? But the first thing we're going to do is we're going to isolate the n's. So what we're going to do, of course, we're going to take the additive inverse of this 57. Actually, why don't I just want to do that in red. Do that in red. Okay, so we're going to go minus 57. Okay, and remember, with the whole balance idea is we have to go ahead and subtract 57 from this other side as well, okay, because we are always trying to keep our equation in balance. All right, so now what we have is we have 2n, okay, and then just plus 0, might as well throw that in there, equals 87. All right, I'm sorry, equals 80. Equals 80. And this looks very familiar because if you look at that, no, not that one, but actually, yeah, this one right here. So you can see where we did that exact same thing. We did it right here. We took 137 and we subtracted away 57. All right, and just like we are doing right here in this area. Okay, so now I have 2n equals 80. All right, and I'll just bring that back up here. So 2n equals 80. So here's where I'm at this point. Now what I'm actually going to do is I need to, again, as we had said, I need to isolate, and I want this to be 1n over here. And the way I can get that to be 1n is to go ahead and divide the 2 by 2, or to multiply by the multiplicative inverse, okay? Because I am trying to get that to be 1n. So I could do 1/2 times 2n, okay? And that is going to equal 1n. If I do the same on this side, 80 times 1/2, that is going to be 40. So there we come to it. N equals 40. And I did the same thing over here when I divided 80 divided by 2, okay? And I got 40 feet. That's the same thing here. We've actually either, you can multiply by the inverse, or you could divide it by 2. That's exactly what we're doing, actually, is we're dividing by 2. Okay? Okay, so we're going to do this next example here called swim practice, and I'd like you to actually lay out a table chart that looks like this, because what I would like you to do is I'd like you to solve it using a tape diagram in the one section, and then I would like you to go ahead and solve it algebraically in that middle section. And then next to that algebraic solution, I'd like you to explain step by step what you are doing. Now I'm going to be adding an if-then component to this, so when you come back, yours may look a little bit different, but hopefully we could learn from that. Okay, so let me go ahead and read this to you. Jenny is on the local swim team for the summer and has swim practice 4 days per week. Okay, I like to highlight or underline these things I need to know. So 4 days per week. The schedule is the same each day. That helps. Okay, the team swims in the morning and then again for 2 hours in the evening. If she swims 12 hours per week, how long does she swim each morning? Okay, so here's what we're trying to solve for. This is going to be our answer. Okay, this is our unknown right now. We don't know how much she swims in the morning. What do we know? We know she swims 4 days a week. We know she swims same each day, and she swims 2 hours in the evening and 12 hours each week. Okay, so I'd like you to try this by yourselves, to lay it out. If it doesn't look, when you come back and you want to make some improvements, absolutely do that. But go ahead and pause right now, and come on back after you finish this. Okay, I'm going to show you my the tape diagram I came up with. I haven't done it algebraically yet, but I just wanted to show this to you, see if you had it looking very similar. You might have had some difficulty just figuring out how to draw up your unknown. I'd be curious to see if you did it another way that you think works just as well. But what I did here is that I had 4 pieces to the tape diagram, and those 4 pieces, of course, represented the 4 days. Okay, right here. Those were 4 pieces. Those are each of those is one of those days. Okay. Now my 2, of course, came from the evening. All right, so 2 hours each evening. So each day I'm going to have that 2. I know, but I have to add in all the morning. Okay, every morning, because she says she swims the same amount each day. So I used x as my unknown. Okay, so I had x plus 2, x plus 2, x plus 2, x plus 2. Okay, each day. So what I needed to do then, I knew that the entire time that she practiced or she swam was 12 hours. Okay, therefore, I know she practiced swam 12 hours. That goes right there. I have to take away the 8 that I already know about. Those are the nights. And then I came up with 4. Okay. So now that 4, okay, I have 4 hours. And I just have to divide those by 4. Okay. Because I have 4 days. So if I have 4 hours left to practice, she has 4 hours left to practice in this week, and there are 4 days that she practices, that's going to be 1. So she actually practices, or she swims 1 hour each morning. Okay, so 1 hour each morning. Okay, each morn. Okay, and that's how it looks like. That's what it looks like. Doing it tape diagram. Okay. So again, if you haven't done it algebraically yet, come on back after you have looked at this. Maybe this has given you some ideas on how to change the way you did it algebraically, or maybe not. Okay, I haven't written in any of the explanations over there to the right of this algebraic solution here, but hopefully this doesn't confuse you too much. They're emphasizing this if-then idea here, so I just wanted to write it like this. Hopefully this will come up in the future, so it'll be helpful, not just confusing. Anyway, it starts off like this. So my first if statement is this: if 4 parentheses x plus 2 equals 12. Okay, and where I got that from is I have these x. See these x plus 2's here? They're over here in the parentheses, right there. And then there are 4 of them. So 1, 2, 3, 4. So that's 4 x plus 2's, and that's what this this here is standing for right here. This is 4x plus 2's. Okay, if that equals 4x plus 2 equals 12, and of course that 12 is derived from here. Okay, then 1/4 for x plus 2 equals 1/4 times 12. Okay, and that's this whole idea of the multiplicative identity. Okay, and that's when we make our way to 1. A multiplicative identity is 1. Okay. Okay, multiplicative identity, and the way I achieve that multiplicative identity, or 1, okay, because I'm trying to solve for x now, trying to get x down to 1, is I go ahead and multiply it by its inverse, okay, and that's what we did right there, 1/4 of 4, and then 1/4 of 12, okay. And the reason I multiply only the 1/4 here by the 4 is because I have 4 of these x plus 2's. Okay, they sit by themselves. I'm trying to get that down to only 1 of those x plus 2's. Okay, so then so that equals that. So then if, because now what I've done is I brought this down here, and then 4 times 1/4 is the 1 that's right here. Okay, these two go down to there. So that's 1 x plus 2. You don't really need that 1 over there. Okay, but equals 3. Because 12 times 1/4, which is the same as 12 divided by 4, is 3. Okay, so if that is the case, if this is the case, then x plus 2 equals 3, because all I've done now is I've just taken away, eradicated this 1 right here, because I really don't need it. Okay, all right, that's a kind of a weird extra step there, but I'm throwing it in there anyway. Sorry. The next if is if, again, just bringing that one down, if x plus 2 equals 3, then x plus 2 minus 2 equals equals 3 minus 2. Okay, and again, this is the additive identity, or actually we call the additive inverse. Okay, the additive inverse. Additive inverse, which is going to get you 0, and where it gets you 0 is right over here. Okay, because I'm trying to get rid of this 2, because, as we have emphasized, trying to isolate this x by itself. So I eradicate that 2 by adding its additive inverse. Okay, and because what's going to happen later on in algebra is this is not always going to be a positive 2 on this side. This could actually be a negative 2. And what I would have to do to get that to be 0 is I would need to actually add a positive. Okay, I'd need to add a positive to it. In this case, I am actually adding a negative number, that red -2 there. Okay, so again, what I do to one side, I do to the other, just like I did up here. Okay, keeping that balance always true. So then I'm going to end up right here. So now if x plus 0 equals 1, because that's what we end up getting, because 2 minus 2 is 0, and then 3 minus 2 is 1, okay, then x equals 1. And there you go. And that is our algebraic solution. This last one is known as, this is good to know, this is known as the additive identity. Okay, anything plus 0 equals, I'm sorry, hold on a second. Yeah, anything plus 0 equals that number. Okay. How does that work? I'm sorry, I'm getting a little bit confused here. Identity, I've gotten an I and a T there. Okay, but that additive identity. Okay, when you add a 0 to anything, you're going to get that thing, and so that means x is going to equal 0. Okay. All right. Hopefully that wasn't too confusing. Don't let it confuse you. Just forget it. Alrighty, let's move on to the next example. Okay, the following, these exercises, actually these last exercises here, there are 5 of them. They vary in what they look like, but you can see these 2 right here, they're actually going to give you an equation. Number 3, you're going to have to develop your own equation using the information. Number 4 also gives you the equation. Looks a little bit different. And then 5, you'll have to develop your own equation as well. So I'd like you to go ahead and solve each equation algebraically. Don't need to do this tape diagram wise. If you wanted to use a tape diagram to check yourself, you certainly could, but what I would like you to have written here are all your algebraic steps. Okay, if you can, it'd be really, I'd appreciate it right now if you would use the if-then statements. But if they tend to just bog you down, don't worry too much about it. Please make note over on this side over here, maybe the different kind of properties you're using, maybe the additive identity, the multiplicative identity, and such. Okay. All right. So go ahead, do that. Pause now. Do that to do that, and come on back and we'll check. Okay. Well, I just finished one because I wanted to come back, and I didn't want to have everything up on the screen. I just wanted to see maybe you guys got off track a little bit, and this way you can come and check, and then maybe do some revisions if you needed to. Anyway, I just went ahead and I made this the if statement because that's what it is, right? So if 5x plus 4 equals 19, then I can go ahead and apply this additive inverse to get this side to have a 0. So what I did is I subtracted 4 from that side, subtracted 4 from that side, came up with this. If 5x equals 15, because that's what it's going to result in, then 1/5 times 5x equals 1/5 times 15. Therefore, if 1x equals 3 after doing the division or doing the fractional multiplication, then x equals 3. And that would be my answer, x equals 3. This over here, I use multiplicative inverse there, and I use the multiplicative identity at the end. Okay, because it was 1x equals 3, therefore x equals 3. Okay, so yeah, I'm going to pause again, and I'm going to finish. I'm just going to go ahead and finish the rest. Okay, I thought I would come back here and actually do just go ahead and do the second one, and then talk about that third one, because I'm thinking maybe some people might be having issues in starting out that problem. So let's go and do the second one here. The B, number two. A little bit different than ones that we've done in the past, because we're going to end up with a fractional answer. So we had the if, of course, if 15x plus 14 equals 19, then if we take away 14 from both sides, we end up with that. Okay, and if that is the case, we can go ahead and use the multiplicative inverse of 15 and multiply that by both sides. Okay, and we would end up getting 1x equals 1/3, and the way I would get 1/3, because if I multiplied on this side 1/15 times 5 over 1, you can see I will get 1/3. Okay, hopefully that's easy for you to see, and if you've got 5/15, you know you could reduce that to 1/3. Okay, so that's what that answer is, x equals 1/3. But now down here, I just want to read this problem out to you. It said, Claire's mom found a very good price on a large computer monitor. So she paid $325 for a monitor that was only $65 more, which is going to mean you're going to add $65 more than half the original price. Okay, so what was the original price? So that's the unknown. Okay, so we need a letter to stand for the unknown, the original price. So we can go ahead and choose X. So we had half the original price. That's what was written over there in the problem. So that's half of X, because X stands for the original price. Half of X plus 65, because this thing was $65 more than half the price, okay, equals 325, which was the price that she paid. Okay, so if you start from there, then you can work your magic from there. Okay, and again, the way we've been doing it, let's just go ahead. We can just complete this together if you haven't done it already. Then half x plus 65 minus 65 equals 325 minus 65. and that's going to go down, then, and then we have if 1/2 x equals 260, then we would go ahead, and now we need our multiplicative inverse again, okay? And now, but now we're looking at 1/2, so we need the multiplicative inverse of 1/2, and that is going to be 2, okay? That's the inverse, so we're going to go ahead, then we would do 2 times 1/2 x equals 2 times 260, so that means x equals 2 times 260, which is 520. So the original price was $520. Okay, $520. And you could watch that again if you want to. The only big difference was now our multiplicative inverse of 1/2 is 2, because that's not always going to be a fractional value. Because if you start with your value here, 1/2 x, the inverse of that is going to be 2. Okay, and that's what happened here, which is going to actually increase this number over here. Okay, all right, let's go to the next page, and why don't I have you guys go ahead, and this time I will not come back until I have finished all of these, or these two. Okay. Okay, well that number 5 was probably, I'm anticipating it was probably difficult for some of you. So I haven't completed, I just wanted to color code it so we could look at it together, and then we'll go ahead and solve it together. Some of you may have gotten it, but I'm just a little worried. And again, I want you to get it step by step in an if-then fashion, somewhat if-then fashion. But let's go ahead and do this this number 4, and just show you what I did here. Again, this looks similar to others that we've done. So if 2 parentheses x plus 4 equals 18, then I'm going to go ahead and take my multiplicative inverse of 2, because I'm trying to isolate the x on that left side, and therefore get that to 1. So then if I multiply 2 times 1/2, I'm going to end up with one of these, 1x plus 4, which is represented here, and then half of 18 is 9, which is represented there. So if x plus 4 equals 9, then I can go ahead and subtract away the 4 from both sides, okay, with my additive inverse of 4, because I'm trying to get 0 on that side and isolating x. So if x plus 0 equals 5, then x equals 5. Okay, so that's that one. Hopefully everyone's gotten that down. Okay, now with this one here, lots of different parts. And one thing you have to understand, and maybe some of you didn't know what to do with the 60 miles per hour, but this 60 miles per hour is a rate. Okay, that is a rate. We need the miles per hour. We know that the entire distance of the trip was going to be 600, and that was right here. So that was very obviously going to sit there. Whatever we added on the other side, the left side, was going to equal 600. The m I made as I made our unknown, and I called it m for miles. Okay, so we're trying to find the remaining time left to drive on the second part of the trip. Okay, so that is the remaining time. Okay, you can see that here. It's not remaining time. It's not remaining miles, but it's the remaining time. Okay, that's remaining time. That's right there. So maybe it shouldn't have been m, but whatever, it is m now. Okay, and plus 4, because 4 we've already know he's already driven 4 hours. Okay, and that's over here. I've circled in purple. Okay, so inside of this parentheses is going to be hours, and outside of here, outside the parentheses, is my rate. Okay, so if I know I am going, I'm going to just explain this a little bit, because I'm quite sure many of you did not get this, and I do understand why. You haven't worked with rates a lot, and we just started rates, so they're expecting a lot from you here with this number 5, okay? And setting this problem up was probably the most difficult thing for you to do. I know that, okay? So we have the 60 miles per hour, and the way you're going to find out, see if you have 60 miles per hour, so we know that we have that this is our speed equals, our distance, okay, times time, okay, or our rate equals distance times distance divided by time, okay, and this should be r, and the r is our speed or miles per hour. R equals d divided by t, okay, so we have our rate, but now we're trying to find out, now we're doing our distance over here. So if we turn it into this is our, so let's bear with me for a second, okay. All right, and again, I know this had to have been hard. So if we know that r, the rate, equals distance divided by time, okay, because that means this would be our miles per hour. That's what that stands for, miles per hour, d divided by t, or d per t, distance per time, miles per hour, okay. It works out that also d, if we figure it out for this, equals r times t, okay. And again, I know we did we talk about this? A little bit, okay. So d equals r times t, all right. We have the d, that's the 600, and that comes from up here. We've gone they're going to go, the whole trip is going to be 600 miles, okay. So we have the d, that's here. We have the r, that's here, 60. So now we need to multiply that r times the t, which is right here, which we only know half of, or part of. We only know the 4 part. There is a missing piece right here, okay, and that we have called m, which doesn't seem to work out so well for me, but anyway. Okay, so let's erase a little bit of this here, okay. So now that is explained, hopefully explained, and hopefully you understand. I'd love to go over it again, but I'm sure most of you don't want to hear me talk anymore because we are nearing 43 minutes right now. Okay, now we'll just go ahead and solve. So we know if 60, I just want to clean this up because I've kind of explained all that. You can go back and look at this again if you want, but if 60 m plus r equals 600, okay, and again I got that from this rate equation, okay, a little bit backwards, the d happens to be on the right up here, okay. If then I know I can go ahead to clean this up, I can go ahead and multiply by the multiplicative inverse of 60. So I'd have 1/60th times 60 m plus 4, okay, equals, okay, I'm going to have to erase all this here, get out of my way. Sorry, because that is very helpful stuff. Equals 1/60th times 600, okay? And again, of course, you know, this is going to look like, we're going to just cancel out this. That's going to be 1, multiplicative identity. So m plus 4 equals, and then if I go ahead and do my multiplication here, boom, boom, equals 10 minus 4, hold on a second, yeah, this is going to equal 10, okay, all right. Now we have m plus 4, at this point we have m plus 4 equals 10. What do we need left to do? We need to get rid of this 4. How do we get rid of this 4? M plus 4 minus 4, okay, because that's going to get rid of that, equals, of course, 10 minus 4, because that is on, I got to do the same thing on both sides, and therefore we know m equals 6. Okay, because 10 minus 4 is 6. Alrighty, so that would be our answer right there. There are 6 hours remaining in this trip. 6 hours. Okay, so it would be a total of 10 hours, which would make a lot of sense if you were to ask the question. I'm going to erase all this, if you don't mind. I think you do. Okay, which would make a lot of sense if we add that 6 hours plus the 4 hours we knew about. That would be 10 hours. And if you're going 60 miles per hour, okay, what would we do? We multiply that times that, and we'd end up with 600. Okay, and that would check out. Okay, so again, just one more time. Maybe you could write this down. Many of you, most of you, all of you. Okay, this idea of this rate, this speed rate, okay, is r equals distance divided by time, or distance equals rate times time, and time equals rate times distance. Okay, so okay, is that right? Hold on a second. This last one's not right. Yeah, time equals d divided by r. Okay, sorry about that, because that's probably the easiest one of all. Yeah, so these three are really good to have when you talk about miles per hour. Okay, and that's how these work. 2 involve division, 1 involves multiplication. Okay. All right, so that brings us here to our lesson summary. Okay. And I'll just go over this now, and then you guys can go ahead and get your problem set done. I won't kill too much time here. Forgive me if any of this is taking too long. You know, it's just my goal to, to be thorough. And I don't intend to bore, though I know I must. Here we go. Lesson summary. We work backwards to solve an algebraic equation. Okay, that's what they're saying here. I'm not sure we talked about that, but anyway, for example, to find the value of the variable in the equation 6x minus 8 equals 40, first we would use the addition property of equality to add the opposite of 8, negative 8, to each side of the equation and arrive at that. Okay, and here's it's interesting that they're put this example in here. Really interesting, because we haven't actually seen this. We hadn't seen this before, but I did mention it, because right now you have 6x and you have minus 8. Okay, we have a negative 8. We always had plus something there. So you're going to add the opposite of negative 8. Okay, before we might have had 6x plus 8, and of course we were always subtracting that away. Okay, now we're actually going to add. We would actually add this 8 to both sides. Okay, we hadn't done that. We hadn't seen that before. But that's the way it works. So always remember that it's not about subtracting a number away. It's just about adding the opposite. Okay, very, very important. Okay, adding the opposite. So then we would go ahead and do that. All right, and now that's to use the additive inverse property to show that, this negative 8 plus 8 equals 0, and that's what's really important. Okay, but then again, we have to do the same thing to the other side. Okay, because you have to add that 8 to the other side as well. So this is where you're going to end up. 6x plus 0 equals 48, or 6x equals 48, and they're just saying that's the additive identity anytime you add 0. Okay, which is this is kind of irritating, I must say. But anyway, okay. And then number 4 says, then use the multiplication property of equality to multiply both sides of the equation by 1/6, which is actually the multiplicative inverse of 6. And when we do that, we're going to go 1/6 of 6x, 1/6 of 48. We know 1/6 of 6x is 1, okay, and then we know 1/6 of 48 is 8. Therefore, 1x, or x, equals 8. Okay, so yeah, our lesson summary is actually just a little sample problem, and that was it right there. Kind of sums it all up, and that's that whole idea of, I guess, of working backwards, taking things apart to get to the solution, because we get down to the where 1x, how much is one of our unknown worth. That's where we want to get. Okay, so go ahead and finish your problem set and do your exit ticket, and see you in lesson 23.